Burp is, you're probably in the wrong room, or the right room, hopefully, right? My name is John Gorenflo. You can follow me on Twitter and my very erratic tweeting. Talk is about Burp Collaborator, mostly because when I started researching it to use it in my pen testing and application testing, I couldn't find much information about it other than the original blog post from Portswear when it came out. So in my searching, I found two definitions. I think one was created by management because there's some synergistic leveraging going on in terms of gas releases. And then the other option is Portswear's tool for out-of-band testing. So, I think technical people came up with their own interpretation of the management definition, but that's the way it goes. So, what does it mean? What is Burp Collaborator, and what does it do for you as an application tester, or what can it do for your organization? So, Burp Collaborator looks for ways to entice an application to interact with three services external to itself. Right? The Burp scanner is going to inject things into your web application to try and force it to do an interaction over DNS, HTTP, or HTTPS. Okay, so what? So as of when I put this together was Burp 1.6.36. It's now at the .39. They release one, it seems like, every week. But constantly up to date. There are three findings inside Burp's scanner specific to Burp Collaborator. You have the external service interaction over DNS, an external service interaction over HTTP, and out-of-band resource load over HTTP. And the HTTP ones there can be HTTP or HTTPS. So for the external service interaction over DNS, Burp classifies this as a high severity. But what it means is the payload that went through from the Burp scanner into your web application on some system somewhere forced it to do a name resolution of the payload. And so what that means is as the application starts processing what you sent it, it sees something that tries to resolve the domain name, and it reaches out, uses recursive DNS, and makes it all the way out to your Burp Collaborator server, who then responds back to the internal server. So if this is a server that's in a secured portion of your network, you've all of a sudden have a server deep in your network that's reaching out to an external DNS server. It's potentially bad for everybody. So the external service interaction over HTTP goes a step farther. Basically what this means is not only did it do a name resolution to try and find out what the IP address is of this host name, it also reached out over HTTP or HTTPS and tried to grab something from your Burp Collaborator server. So you've forced an internal server or a web application to try and load or grab resources from another place. That's never good. If you see this, dig into it because it's bad. What you can do with it is load things in, but you can also then use it as an attack proxy to either attack internal to other systems on the internal network, or you can use it to attack third parties, or potentially look at the loopback services that are running on the host that you're attacking. The out-of-band resource load, very similar to if you're familiar with remote file inclusions. It's the same type of vulnerability here, except you need to think of it in terms of a script that's then sent back to the user and processed in the browser instead of something that's maybe like a RFI, a remote file inclusion for PHP, where it would run PHP shells or that kind of thing on the server side. So how does it work? What's actually happening with Burp Collaborator? So in traditional web application scanning and traditional Burp scanning, your payloads leave the Burp scanner, go directly to the application server, are processed, and then you get a response back. But at that point, you're limited to what the server will return to you. Burp Collaborator and tools like it will turn this testing a little bit on its head, because you're not only going to get that conventional testing across the top here, you're also going to see what those external interactions are. So Burp Collaborator server runs as a separate process. You send your requests and your payloads through. It hits that target application. If the target application is vulnerable to something that will execute these interactions, it'll reach out, contact the Burp Collaborator server, and then over the monitoring connection to your Burp Suite client, you're going to get that interaction back. You're going to be able to see what the interaction was from the Burp Suite to the application to the collaborator server. So what does that look like? For DNS, it looks a little bit like this. I ran these tools against the WebSAP program, which is it's included on the OWASP Broken Web App VM. So it's designed to help you test scanning tools. So if you're looking for a tool and you want to guarantee to find some vulnerabilities, it's a great tool to help you see that and see what the interactions are for those tools. So as you can see here, we've sent it through, and highlighted in red there is the payload that it sent through. And you'll see that it has my domain name listed in there. It's probably a little bit easier to read from the right to the left. So my domain is funsec.net. You see bc.funsec.net, and in front of that is just a long string of random text. And the reason that's there, and we'll cover it a little bit when I show you how to set up a collaborator server of your own, is you set up Burp Collaborator server, it becomes a DNS server, and then it will respond to any DNS request that it gets with its own IP address. Every time, no matter what. So part of what it does is it sends random strings across and then sees if it's resolved on the other side, and then keeps that interaction and reports that back to you. And then can tie that to the specific request you made to the web application that caused the interaction to the collaborator server. So continue, this is the information you get back from for the interaction on the collaborator when you're looking at the results portion of the scan in Burp. And then notice the IP address that it has listed there. The interaction that it saw was from a DNS server, not from my IP address. So the DNS interaction here is from whatever DNS server actually resolved the random string to the actual IP address. So with the HTTP and HTTPS interaction, basically goes through the exact same process. You probably won't see these interactions without having the DNS It is. Yes. All right. Congratulations, you guys have an exclusive. So with HTTPS or HTTP and HTTPS interactions, you'll see that most likely paired with a DNS interaction as well. Otherwise, it wouldn't make it out there. But you'll see that same kind of request go through, and you can see the response down below. You can see the HTML response. Very basic in this because of the WebStep tool that I was using to do the test. But you can see that string come through on the bottom part there. That's to help you identify where that comes through, and that can be an attack payload eventually as well. So HTTPS to continue, this is what you'll see from the interaction side of it. This is when you're looking at this piece here, this is what it looks like to the Burp Collaborator server. So the top part there is the request that went to Burp Collaborator, and then on the bottom part is the response that Collaborator sent back to the original host. Or excuse me, the web application itself. All right, so we've got 3 findings. Now what? So the full potential here is that you have a tool that's going to help you find out-of-band XSS, super blind injections, stored blind injections, deferred interactions, and then potentially other network services as well. You're really limited only to the creativity of the attacker at this point. So for out-of-band XSS, what happens with out-of-band XSS is it's detected. It's very similar to the resource load. So you're going to have those interactions, and at that point you can send a cross-site scripting attack in as the response back. So while you have the vulnerability identified with the Burp Collaborator server, it's not necessarily going to attack it. You're going to have to create your own payloads to... are they mad because they can't see the video? All right, I think we got it. All right, so with the out-of-band resource loads, it have the potential here to then deliver a script back and have that end up in the user's browser as an attack vector. It's not necessarily stored and it's not reflected, and it's not DOM-based. But it's passed in and loaded in from the Burp Collaborator or whatever you force the interaction with afterwards, after Burp Collaborator helps you identify it. And it can be used for other client-side includes with HTTP response header injection and open redirection. So super blind injections, these are the kind of injections without something like Burp Collaborator, you're never going to be able to detect, because you'll send your request into the web server and it will respond to you the exact same way no matter what. So the traditional means of identifying SQL injection or command injection won't necessarily work for you in terms of what you get back from the server. However, with the super blind injections, if you can force that server on the back end to interact, you'll have something with a Burp Collaborator that'll be able to identify that and then give you specifically where that vulnerability was in the web application. So the out-of-band injections, similar to super blind injection, but in this case, you're looking at the things that are sent to the application itself and not necessarily the back end to run through those. Depending on how that application processes the response, it could be vulnerable to any kind of input. So server-side code execution, SQL injection, etc. But what you're doing at this point is once you've identified it with Burp Collaborator, you do the same type of injection attacks that you would do with the web application directly. You send those responses back from whatever server you forced the backend to interact with during your test. So deferred interactions, stored versions of previously mentioned attacks. So basically we're going to put it into a system and hopefully it's going to flow through the system, and at some point something down the line is going to execute what we've put in there as a payload. You're able to link entry points and retrieval points for the application. A great example of this, and he's actually in the room. So Daryl Hyland has a presentation that you can see it at the link here, where he was able to do cross-site scripting attack against a wireless intrusion detection system by putting cross-site scripting into SSIDs. So the SSID is a cross-site scripting attack, goes into the system, pops up on the analyst screen, and launches cross-site scripting. That's playing dirty, right? Not good for anybody. And those are the ones that are probably really fun. So check that out. This gives you the ideas of what you can really do with these kinds of vulnerabilities once you identify them. So testing after DNS interaction. If you get the DNS interaction in Collaborator and you don't get the corresponding HTTPS or HTTP interaction, it means that something processed what you went through as a host name, but for some reason couldn't get out. So you've got some options there as to whether there's like network filtering of some sort, firewalling, etc. So you need to try and either get around that. So if you've got something like command injection, these here are options for Linux and for Windows. I've got a link in the back to see those, so don't bother trying to write them down. Available at the Kung Fu, Command Line Kung Fu blog. But basically, real generic ways to do some port scans and trying to connect to various ports. And at this point, you can use that to connect to different machines on the internal network or potential third parties or whatever. But you can also do this if you run egress buster on another host that you have. Run these commands and do that egress busting to try and see if any port is allowed out. So if they're blocking traditional ports of HTTP, HTTPS, etc., but potentially have random high ports open, allowed out from the secured subnets, that could be an issue as well. So if you've got HTTP or HTTPS interaction, run the Metasploit service authentication captures. See if you can force that system to try and authenticate to you and steal their credentials. Right? It could be an interesting way to leverage these vulnerabilities once you've identified them. And look into the server request side forgery vulnerabilities as well. And then testing for the out-of-band resource loads. What can you do with that? Look at things like the Beef framework. It's a great framework to help you help with demonstrating cross-site scripting capabilities and what can happen with an attack that way. If you do get Beef to launch, you'll be able to get a little bit of information about what kind of system actually connected to you. Was it a backend system? Was it an analyst PC, etc. And then look at the Metasploit browser autopwn. Similar option here for looking at the analyst PC, or if it is a person that you end up who ends up reaching out to you. and compromise their machine that way, and maybe even get them interpreter shell, right? And then the local host services. So if you can load out-of-band resources that way, look at what's running on the local host. At certain times, there's applications and information you can get from the local host of a machine run on the 127.0.0.1, and pull additional information about the machine that might help you exploit it. So what's still missing from it? In Portswigger's initial announcement of Collaborator, they mentioned a few things that they were going to hopefully be adding in the future. And I'm really looking forward to when they do, because I think that'll make it a lot easier to leverage what you find with the burp scanner and do some of the more advanced attacks possible here. So the two pieces they really talked about were the Burp Collaborator client and then the Burp Intruder integration. So the Collaborator client will be something that allows you to configure exactly what the Burp's Collaborator server is going to do if there is an HTTP or HTTPS interaction. So you'll be able to specify what that payload is. You can put in your own cross-site scripting attack or whatever. And then it'll work in concert with the Burp Intruder integration. So whereas the Intruder will allow you very specifically to pick certain parameters as you're doing your tests and repeat or iterate over something and be very targeted in how you're scanning and attacking the machine. This will integrate in sort of like the way the Burp extender works with the payload generators, and you can pull from another extender application and use that for the payload generations that the Intruder sends. So other roadmap items that they mentioned were out-of-band versions of all of the input-based attacks and checks that they have in Burp. I've not quite seen that yet. Detection of various super blind vulnerabilities, checks for stored versions of the relevant vulnerabilities, and then handling deferred interactions, and the support for other network services associated with payloads, and manual testing tools. The manual piece, I think, is when it'll be the most valuable there. So what does it store? What it does have is the source IP address that initiated the interaction. So if it's leaving your organization, whatever your perimeter IP address that it comes from, it's going to be in the Burp Collaborator server. It's going to have the unique string that was used to identify the request that went through, so that you can tie the request from your Burp client to what the Collaborator server sees. And it's going to have any application-specific data that's included in the request. And since you don't necessarily know what that is, it's hard to tell what the risk is to that being out on a public server. Specifically, what it does not have is any information about your Burp client or you as the individual that's running it, your license information, etc. So the Burp Collaborator polling, same as what we talked about before. The polling is the monitoring and control piece on the bottom left there. So when it's doing the polling, how is it securing the data? How is it making sure that everything stays private when it goes to the Burp Collaborator server? So each instance of Burp, when you start it up, it generates a secure key. And that secure key is then used with cryptographic hash and a random identifier with every request. And then when you do the polling, Burp marries those two up and sends a request up to the Burp Collaborator server and says, have you seen anything that has to do with this key? The Collaborator server does its own cryptographic check to match them up, and then only returns back what came from your instance of Burp. And then the server takes that and returns it back. So I think it was 1.6.29, they added the ability that when you save your session in Burp, it actually takes that private key and puts it in the saved session. So if you restore a session back, you'll get that key and it can check for those interactions. However, they don't stay out there forever. It will delete them after a period of time. But point being there is make sure you back up. If you do save your sessions, do the encrypted version of it so nobody can retrieve your key out of there. So Burp Collaborator polling, this is what it looks like as it goes through. You can see the requests go through. It sends the string as a GET parameter, and this was captured via Wireshark. And then returns back and has, you can see a JSON list of the interactions that it had tracked since the last polling update. So what does the Collaborator do with the data? The details of the interactions are stored in ephemeral process memory only. They are never logged to disk unless you're doing something on the server to log that yourself, such as packet captures or something like that. It's never recorded at all. And the details of the interactions, once they're retrieved from Burp, from the Collaborator server, are deleted. And if they're not picked up after a specified time, they're deleted as well. However, the documentation doesn't specify how long that is. And there's no administrative function on the server side to be able to go through and look at those interactions, see what they are. However, if you control the server, you can do a memory dump and see what's inside there, if you so chose. So if you want to set up a private server, and I recommend that you do if you use Burp in your environment, it's really not all that difficult, but a few things you have to know to be able to do it. So you've got three options. And first, if you're a Burp user and you don't know it, Burp Collaborator is on by default, and you're using Portswigger's public server. So something to note if you're an app tester and you use Burp. Middle option there is obviously turn it off, and then the option below that is when you set up your own server. And you can set up the server name and the polling location. The reason to set it up for yourself is, one, you can test and then have all that data come to you, and you have to be less worried about somebody compromising the information and seeing what's potentially in the Burp Collaborator server. Not a huge risk to your organization, but depending on the sensitivity of the data or the application that you're testing, you may or may not want that going out to a server that somebody else controls. Then the other reason you want to do it is that when you're testing on your internal network, you may have filters on your perimeter firewall that would prevent interactions to the outside world, but would allow the interactions to happen within your own network. So again, you would see more with that internal server than you would potentially from the external server. But it's something you should probably think about running a scan with connected to both, so you can see which way it goes if it goes both directions. If it will make it to internal and also make it external. Yeah, absolutely. So it's included with Burp Suite. If you buy it, you own it. You have it. It's part of the... Yes. Yeah. It uses the same Java file as Burp, so instead of just launching Burp, you launch it from the command line. And I've got some examples of that in a moment. And you just give a --burp collaborator, and you're up and running. System requirements, it doesn't take much. I ran it on a cloud instance. It was like a $5 a month cloud instance somewhere with 1 CPU and 512 of RAM. And it did just fine for me. So not a lot to run it. You can probably run it in parallel on your machine. However, and these are the commands I was mentioning just a moment ago, straight out of the documentation. So you will need to set up DNS. And we're going to talk briefly about that here. So DNS, if you're not familiar with DNS and DNS recursion, make sure you understand how that works. Because if you're going to set up your own Collaborator server, you've got to set up your own domain or subdomain to work with Burp. Without that, you're not going to get a whole lot of interactions, right? So for me, to get it set up for my domain, I created 2 records. I created an NS record that pointed to ns1.bc.funsec.net, and I created an A record that pointed to for my IP address for bc.funsec.net. That's it from the DNS perspective. And then once you're running on Burp Collaborator, you're good to go. So you can see here, you just do the NS lookup on the left. I just did it for my domain in bc.funsec.net. Then on the right, you can see at the bottom right there, just did random text.bc.funsec.net, and it will always respond back with its own IP address, no matter what you send it. This is a config file. The example out on the site has a lot more information to give more examples, but this is as simple as you can do it. Got to put in what your domain is, and then the metrics information. So the metrics path, and you'll see this in a moment as well, gives it somewhat of a secret key in terms of being able to see the metrics of how many interactions you've had with your application. And then the address whitelist. So if you want to restrict the people that can see the polling information, you can specify what IP addresses that can actually get to your polling information. additional options you can put into the configuration file. So you can see you get a little bit more specificity there. The specific ports for the different services that you run, etc. So if you want those to be non-standard, if you find you've got a weird port running or allowed out somewhere, you can have that set up that way as well. And then notice, I did call out here, in the example on the site, they give an example of what the path is for the metrics. You don't have to use that, but don't use that. It's your example, so I'm sure if you find a Burp Collaborator server somewhere, you're going to find one at some point that has that as the secret key for the metrics path. This is the basic information you get from the metrics. It's really not all that interesting, but you can kind of see how many interactions there were per hour, etc. And then lots of different options to get more granular in the configuration file. I won't bore you with all those details, but if you need those, the advanced options are there. There's additional information for the polling. And more ways to run DNS. It gives you a bunch of different ways, especially if you've got a server that maybe is behind a firewall, so its public IP address is different than the IP address on the local host. Dig a little bit more into these details. So how do you spot one? Like if you think you've maybe found one, if you just hit it on HTTP or whatever port it's listing on for HTTP, this is the page you get. So if you're a pen tester and you're out doing a test and you think you might have found one, that's one way to see it. And then I thought, well, what's it look like if I start running some of the DNS recon tools on it? So basically all the tools give up pretty quick. They figure out that it's getting, it'll give it a junk request, and when it gets a response, it knows that it's just going to respond to anything. So both DNS-enum and DNS recon both just bail because they can tell that it's responding to everything with the same IP address. Those are references. Any questions? Since April of last year, so just about a year. They keep adding to it. They've been adding bits and pieces for quite a while. I think it was October when they added the ability to save your session and have the key be saved as part of that. Now, this will work against a machine that you don't, because when you submit the request in, the system you're attacking, either that system or a system on the back end somewhere, is going to get that payload, and it's going to try and do a lookup on that domain name. Well, it's my domain. So if we go back, I guess I did kind of skip over the DNS. Figure out where. There we go. All right. So when you're doing DNS resolution, it always starts at the right. We think of it from left to right, but it's doing the resolution from the right. So the resolving name server is going to be not the system I was attacking, but the DNS server that system is configured to use. Okay. So it's going to get, for me, it was funsec.net, right? It's going to start at the far right, and there's an imaginary dot on that far right, and it does DNS recursion from there. So it gets that dot, and it goes up to the root name servers first and says, hey, who has net? Gives it an IP address, and it does the recursion out and says, okay, top-level domain, which is the .net, says, who has funsec? And that will respond back and say, okay, go to the authoritative name server, which is either you host your own or it's at the company where you register your domain name. And it'll respond back with, okay, this is authoritative DNS server for funsec.net. Mm-hmm. Yes. Yep. Yeah, so I mean, if you set your own up internally, you could do that, but you've still got to have that authoritative name server.
Like, what if you had an app that was doing that internal DNS for all kinds of other internal links and
Mm-hmm. It's potential, like all the findings that it talks about, those first three that we talked about, you have to do the research to find out if they're actually vulnerabilities. Because there's a potential that it's an intended purpose of the application. Now then it's a matter of what can I do with it as an attacker? Can I make it do what I want instead of what it was designed to do? And if you have systems that are taking input from users via web application and then doing things on the back end and reaching out to other systems, I mean, you've got a lot of potential there for things to go wrong. So it would be a good way to check that. But this is more to help people identify applications that are doing that or can do that weren't intended to do that. Well, it would depend what's on the box. So a lot of machines will have services that are listed on loopback only, so that you have to be, in theory, on that box to access it. So maybe an administrative console. So if they've configured a Linux box, that you have to SSH to it and then use that as like a SOX proxy and connect in or something like that. Yeah, that'd be bad. Yeah. Yeah. If you couldn't hear what he said, there was a recent attack with 1Password that had the passwords going in clear text across the loopback address. No, unfortunately, I've not been able to use it in a live test. Like when I started doing this, I was hoping to have that done before I had to give the presentation. But mostly because a lot of organizations don't want to use it internally yet, or you have to go through processes to get it, because not the average Fortune 500 is going to throw up some flags if you say, "Hey, I want to create my own DNS server over here." You know, it's not an easy thing to get done in the average big corporation. And then on the other side of that, being able to use it if you're doing pen testing with clients and that kind of thing, it depends on the sensitivity of the test, right? So I've just not had that opportunity yet since I started looking into it. But again, part of the reason I did the presentation or started doing the research is because I couldn't find much information about it, and hopefully more people start using it and trying it themselves and sharing. Any other questions? Yeah. I mean, I guess you could say I wouldn't call it a trust relationship. I would just.
Usage of information is coming from some source that you never.
I would say forced interaction before I say trust relationship. Sure, if you're authorized to test the cloud that you're testing. Anything else? All right. Right, right. So that's it'll get better when that was the piece I was talking about when they finally get the Burp Collaborator client built and integrated in. But to this point, that doesn't exist. All right. Thanks for coming.